Hey Calculus, it's Mr. Florio. I'm going to do the 2.3 notes. I'm going to make a video just in case there's an issue in class where you can't watch the video or watch me live in class. So you can find the notes in their class notes under 2.3, evaluating limits analytically. The first example is just going to be where we left off in class. I want to find the limit as my function approaches 2. If you plug in 2 for x, 2 squared is 4, and 4 minus 4 is 0, so the top is 0. 2 squared plus 3 times 2, that's 4 plus 6, which is 10. 10 minus 10 is also 0. We get that indeterminate form again. So we have to do something different, and I want to do this analytically, so I don't want to just draw a graph and estimate it or make a table and make a guess. I want to find it out for sure. So the idea is let's try to factor and see if something nice happens. So see if we can take a different approach, because right now it's indeterminate form. We need to take another look. So x squared minus 4, that's difference of squares. We can factor that. X minus 2, x plus 2. And then the bottom, we factor that. What multiplies to negative 10, that adds to 3. I think that's going to be 5 and negative 2. And luckily that 0 that we were having issues with, the as x approaches 2, 0 gets divided out. And so we can just evaluate this function where I plug in 2 for x. So I have x plus 2 over x plus 5, and I want the limit as x gets infinitely close to 2. That's just going to be 2 plus 2 over 2 plus 5, which is 4/7. So we can find the limit by just factoring. If that 0 that we're approaching divides out, then that 0, 0 won't be a problem. We can just plug into the twin function. So we're going to evaluate by factoring, by rationalizing. I'm going to call it conjugate. Actually use the conjugate here, and by a common denominator. So next example, take a second to copy it down, pause the video if you need to, is going to be factoring this guy. And the issue is factoring the top isn't so bad. It's factoring the bottom. By the way, I always start by plugging in the limit first. But just if you do plug in 1, you can double check me. You get 0 or 0. But when we factor it, the top is simple enough. That's going to be, what, x minus 1, x minus 1? The bottom, not so much. We have a cubic. There's 4 terms. What we could try is synthetic division, which is something you probably did in Algebra 2. I don't know if you did it in pre-calc. Definitely a throwback Thursday moment right here. So let's take a minute before we jump into synthetic division. We factored the top. It's x minus 1 squared, or x minus 1 times x minus 1. So the 0 that we're looking for is 1. Does x minus 1 factor out of the bottom? Because if it does, then we can divide them out and be okay. If it doesn't, then we're not okay. So the only factor I'm worried about for this denominator is x minus 1. Is x minus 1 a factor of x cubed plus 3x squared minus 6x plus 2? So that's what we're going to check. So is the 0 1? So if you plugged in 1, you get a 0 there. Is that going to be a factor? So I'm checking out if 1 is a factor. In synthetic division, just check out what the coefficients of all of your terms are. So the cubic term is a coefficient of 1. The square term is a coefficient of 3. The linear term is a coefficient of negative 6. And the constant is 2. If we were, all terms are present, right? We have a cubic, we have a degree 3, degree 2, degree 1, and degree 0. If we had no 3x squared here, then we would have to put a 0 there to count for that 0 coefficient. But all the terms are present, so now we can just do the synthetic division, bring down that first term. 1 times 1 is 1. Put it right here. Add these two together. 3 plus 1 is 4. And repeat. 1 times 4 is 4. And then negative 6 plus 4 is negative 2. 1 times negative 2 is negative 2. And 2 minus 2 is 0. The fact that it's 0, this means the remainder is 0. So x minus 1 is a factor. So great, the bottom is going to factor. X minus 1 is a factor. But what's the other factor? And the other factor is right here. This is my my constant. This is my x term, and this would be my x squared term. So you can just keep increasing the degree as you go on. So it's going to be 1x squared plus 4x minus 2. And now we can continue. The x's cancel out nicely. And then I'm going to get the limit as x approaches 1 of x minus 1 over x squared plus 4x minus 2, which if we plug in 1, that's going to be 1 minus 1 over 1 squared plus 4 times 1 minus 2. The top is definitely 0, and the bottom I get, that's 1 plus 4 is 5, 5 minus 2 is 3, 0 divided by 3 is 0. So we do get an answer in this case. The limit of this function as x approaches 1 is 0. And we can get it through synthetic division if we have some trouble dividing. If this factor was not 0, then if the remainder was not 0, then we couldn't factor it. And if we couldn't factor it, then we wouldn't be able to tell what the limit is. Of course, when I give you these, it's going to work out so you can. All right, so now we get a nice nasty looking one with some square roots. This is the second strategy. If you plugged in 0 right off the bat, you're going to get 0 on top, and the square root of 1 is 1. 1 minus 1 is 0. You still get 0 over 0. Strategy 2, using the conjugate. And pause me to so you have time to write it all down. But I'm going to evaluate this limit as x approaches 0. I can't just plug in 0 because I get some weird stuff happening. I can't do 0 with 0. That tells me that I don't have enough information yet. So I'm going to multiply by the conjugate. So the conjugate, I don't know if you remember this from pre-calc. I'm going to multiply the top and bottom by the same thing, the square root of x plus 1. But instead of minus 1, it's going to be plus 1. Do the same on the top and bottom so I don't change the value. So I'm really just multiplying by 1 because everything in green is just 1 because they divide out. But the reason why I dressed it up like this is because some nice stuff's going to happen when you multiply by the conjugate. The top when we multiply, it's just going to be x times the square root of x plus 1 plus 1. Don't forget the parentheses. And on the bottom, we need to FOIL here. I'm going to put these parentheses in because we're going to need them. So what happens here when we FOIL? First, we multiply the first two pieces, which is the x minus 1, square root of x minus 1 times square root of x minus 1. When you multiply those two numbers, you get the square root of x minus 1 squared. The square roots will undo each other, and you just get x plus 1. So that's your first part. So I multiply those two. Then I need to multiply the square root of x plus 1 times 1, which is the square root of x plus 1. Then you need to distribute the negative 1 as well. So we're foiling. So we did the first, the outer, and now we're going to do the inner terms. Negative 1 times the square root of x plus 1 is negative the square root of x plus 1. So that's my inner terms. And then the last term, negative 1 times 1 is negative 1. So that's me foiling right there. And let's keep going. So the whole point of this conjugate and why we did something that looks so out of the ordinary, I'm going to leave the top alone for a second, is these two terms right here are going to take each other out. And that's always going to happen when you multiply by the conjugate. That's kind of the point. And then you have a 1 and a minus 1 taking each other out. And all you're left is with the x. So once we have the x, just divide them out. And now that x equals 0, which is the point that we're looking for, is going to cause some problems. Now that problem is gone, and if I plug in 0 now, I get the square root of 0 plus 1 over 1, which is, let's see, the square root of 0 plus 1, the square root of 1 is 1, plus 1 is 2. 2 divided by 1 is still 2. So that's how we can do it, rationalizing not rationalizing, using the conjugate. All right. And you could have the square root in the numerator instead, and we could still make this work. So if you want to pause and try on your own, feel free. But right now we're trying to find the limit of the function as x approaches 3. So if you plug 3 in, 3 plus 6 is 9. The square root of 9 is 3. 3 minus 3 still gives me 0. And on the bottom, 3 minus 3 is 0. Another indeterminate form. So we're just going to repeat what we just did. So the limit as x approaches 3 of my function multiply the top and bottom by the same thing. Instead of 3 minus the square root of x plus 6, it's going to be 3 plus the square root of x plus 6. Okay. Always use parentheses, right? Not going to hurt. I'll do them top and bottom. And let's keep going. So this is the same thing as the limit as x approaches 3 of 3 times 3 is 9. 3 times the square root of x plus 6 is 3 square root of x plus 6. Let's do a different color here. Negative square root of x plus 3 is negative 3 square root of x plus 6. And negative square root of x plus 6 times square root of x plus 6 is negative. The square roots are going to undo each other because we're going to have the square root of something squared. So we just get x plus 6. Don't forget that parenthesis, it's important. And the denominator, leave it alone. Because we want, hopefully, something to divide out with that x minus 3. And when we simplify the top, I think it's going to happen. So same thing as before, the 3 times the square root of x plus 6 and the negative 3 times the square root of x plus 6 take each other out. And now I'm just left with 9 minus x minus 6. Don't forget to distribute the negative. And we get x minus 3 and 3 plus the square root of x plus 6. All right, so similar to the last one, 9 minus 6 is 3, so I get 3 minus x on top and x minus 3 on the bottom. You might be saying to yourself, do these cancel out? I'm not sure. And sort of. There's a little voodoo magic that we'll do here, but all you're going to do is factor out a negative 1 on the top. So this is the same thing. I got rid of the limit. Factoring out a negative 1 through the top, it'll turn into... let me just do this on the side. So 3 minus x is the same thing as negative x plus 3. And if I take a negative out of that, I get a positive x minus 3. And you could check it by taking the negative x minus 3, and if you distribute the negative 1 in there, you get negative x plus 3, which is what we started off with, 3 minus x, same thing. So that's kind of like a little side work to see the magic here. So the top 3 minus x is the same thing as negative x minus 3. And now we can have that lovely factor divide out for us. So the x minus 3's divide out, and we're good. Let's go plug in 3 now. We have a negative 1 on top. And on the bottom, I have 3 plus the square root of x plus 6. And we're plugging in 3. And what do we got? Negative 1 over, that's 3 plus, let's see, 6 and 3 is 9. The square root of 9 is 3. So I get 1 over 6. So the limit of this big function over here as x approaches 3 is 1/6. All right. Another example is when we have like these fractions and fractions, and just use what we did in the pre-calc review. Let's just get a common denominator. And we're going to see if anything factors out. We'll also do some factoring here, but if I plug in -5 here, 1/5 plus -1/5 would be 0 on top. And -5 cubed is -125, plus 125 would give me 0. So 0 over 0, indeterminate form. We got to take a different strategy. And I'm just going to rewrite this. The limit as the function approaches -5. The common denominator is just going to be 5x. So multiply the top and bottom by x, top and bottom by 5. So we get x plus 5 over 5x. On the bottom, I have x cubed plus 125. X cubed plus 125 is the same thing as x cubed plus 5 cubed. And here we have a sum of squares. So whether it's a sum of squares or difference of squares, we can always factor it. Here's like a little FYI for you. If I have something like a cubed plus b cubed, that's always just going to be, I'll do the plus and minus in a second. You get the first factor will have an a and a b, the second one will have an a squared, an ab, and a b squared. And I use the mnemonic SOAP to remember what the signs are. The first one is the same, so if it's plus, it's going to be, the first one's going to be plus. The second one's always the opposite. So if the first one's plus, that one's going to be the opposite of plus, which is minus. And the last one is always positive. Always positive. So in this case, this is going to be, we have x and 5, x squared, 5x, and 5 squared. 5 squared is 25, by the way. The sign is plus, so same, opposite, always positive. So the denominator will factor into that. And 5 squared is 25. Now we'll do the keep change flip, start doing some simplification. Stuff's going to divide out, and we'll plug in our -5 and be done. So x plus 5 over 5x is my numerator. Change division to multiplication and flip the denominator. So instead of this over 1, it's going to be 1 over all that purple maroon stuff. And let's see, yes, the x plus 5s divide out. Now I can plug in that -5 and not get 0 over 0. So I'm going to have 1 over 5 times -5 times 5 squared minus 5 times 5 plus 25. So that's -25. And 5 squared minus 5 times, so that's 25. Oh, we got to plug in -5. So that's going to be -5 squared. So -5 squared is 25. -5 times -5 is also 25. So 25 and 25 is 50. 50 plus 25 is 75. 75 times, I think this is 75. And it should be, we should end up getting 625. Let me just check on my calculator. Nope. I thought I got 25 when I did this originally. So plugging in -5, right? Let's just do it. -5 squared is 25. -5. Oops. -5 times plugging in -5 gives me another positive 25. And then plus that last 25. So that is 75. And 75 times 25 is a big number. 1,875. So I'm running through this quick. I don't want to make a mistake here. If I made a mistake and you catch me, just let me know. But it's not -1 over 625. I think I got like a negative out of one of these, and the 25, 2 of the 25s canceled. But a negative square is going to give me a positive. A negative times a negative is going to give me a positive, and a positive is a positive. So, anyways, we get that limit there. Here, now pay attention to this one because this one's going to take no time at all. When we plug in the limit 3, 1/3 plus 1/3 is 2/3. And 3 cubed is 27. 27 minus 27 is 0. This is not an indeterminate form. If you remember from the pre-calc review when we did rational functions and wholes, if the zeros didn't divide out, it's a vertical asymptote. So if it's a vertical asymptote, the limit does not exist, as Lindsay Lohan once said. Okay, so no further work. So anytime you get a number divided by 0, the limit does not exist. If you get 0 over 0, that's indeterminate form. Okay. And that's it for this lesson. Your homework is just going to be to practice some problems like that. There'll be a synthetic, there'll be some factoring, there'll be a common denominator, conjugate. So just get some practice, and it's really just a lot of algebra. The limit stuff behind it isn't really isn't the hardest part. The hardest part's really just making the algebra. Anyways, any questions, let me know. That's it.